Overlooked weather phenomenon produces gamma rays in our atmosphere. The electrical effects of a thunderstorm are not confined just to high up in the atmosphere. Close to the ground, Earth's atmosphere hums with intense electric fields that accelerate particles, flinging electrons in ways that force atoms to glow with gamma rays. From atop a mountain in America, scientists have taken a close look at this mysterious meteorological phenomenon. At the Alikhanyan National Science Laboratory's Cosmic Ray Facility on Mount Aragats, physicist Ashtot Kilingarian and his colleagues have been working to understand the thunderstorm ground enhancements, or TGEs. This electromagnetic enhancement, Kilingarian says, has been overlooked in thunderstorm research, but it could be a piece of the puzzle in our understanding of the physical universe, from thunderstorms here on Earth to the cosmic rays that travel vast distances across space. Each day, 40,000 thunderstorms occur, numerous networks detecting atmospheric discharges and satellites with precise optical instruments are monitoring lightning flashes. Still, when we started TGE research, nobody monitored the huge flux of mega electron volt MeV electrons bombarding our planet and space above it, he told Science Alert. We established the Sevan particle detector network 10 years ago to monitor TGEs in Eastern Europe, Germany, and Armenia. Electron accelerators with energies of tens of MeV cover vast volumes in the atmosphere and many square kilometers on the Earth's surface. This huge flux is accompanied by life on Earth through its billion years of evolution and surely influences all aspects of the geospace and biosphere. TGEs consist of electrical fields in the atmosphere generated by thunderstorms. Within these electric fields, electrons are accelerated to high speeds approaching that of light in a vacuum, or relativistic speeds. These are known as relativistic runaway electron avalanches, propelled by the electric field both towards the ground and upward into the atmosphere. It's these electrons that produce the radiation. When they decelerate suddenly, deflected by a collision with an atomic nucleus in the atmosphere, the loss of energy manifests as gamma rays, a form of radiation known as Bremsstrahlung radiation. Using their network of detectors, Chilingarian and his colleagues collected data on thunderstorms across Europe in 2023, performing detailed measurements of the electrons and the gamma radiation that occurred during the 56 intense TGEs they recorded. The most intense TGEs mostly took place from May to July, and the most powerful was recorded on Mount Lomitki Stit in Slovakia in May. For this one event, the particular flux was 100 times the normal fair weather level. In total, there were 7 events that exceeded the fair weather flux by more than 75%. We measure the stable electron flux on Earth's surface, covering 100,000 square meters. Some mechanisms provide this stability for a minute or more, Chilingarian explained. A huge electron beam emerges in the thundercloud where the charge structure changes on the second time scale. Atmospheric discharges kill the potential difference, but the flux is stable. It was exciting to measure, he said. Surprisingly, the researchers also found that the electric field is much closer to the ground than they expected to find. They measured a strong electric field strength down to 50 meters above ground, that's 164 feet. This discovery was astonishing to meteorologists who did not believe it until we presented exhaustive proof, Chilingarian noted. The consistency of the acceleration, able to maintain particle flux for up to several minutes, as well as the low height of the electric field, reveals new details about the structure of atmospheric electric fields and thunderstorms that we did not know before. For example, TGEs might provide a pathway whereby lightning strikes can reach the ground, and their role in geophysics needs to be investigated. The researchers have made an open access TGE database available for the scientific community to explore and analyze. Their thunderstorm research is only part of the work performed on Aragats. This year the sun has reached a frenzy as it approaches solar maximum, at the peak of its activity cycle, sending particles spewing into space powered by coronal mass ejections from our sun. Chilingarian and his colleagues have also detected solar events with the mountaintop equipment, publishing 3 papers with a 4th on the way. Violent explosions in our galaxy also send ultra-high energy particles to the solar system. Recently, pevatrons, sources of 10 to the 15th power EV gamma rays, were discovered. We critically analyzed this discovery based on our knowledge of atmospheric physics, Chilingarian told Science Alert. The synergy of atmospheric, space, and solar accelerators is important for understanding nature. And the findings are due to be published in Physical Review D. This is on Science Alert by Michelle Starr. Please leave your comments. Thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.